the stigma that electric vehicles had for so long was that they were underpowered or they looked ugly. And so now you have many manufacturers who are putting forth their
sexy electric cars.
Electric cars. And so there's still some challenges. For example, they still run on batteries.
Right.
Now, battery, it's like, okay, that was invented in the 19th century. The chemistry was a little different.
Wow.
But if you want to look at sort of the last holdout of a century-old technology within a modern vehicle, it's the battery.
Wow.
Battery technology. Here's the problem. If you have pure solar panels on your car,
okay,
well, what happens if a cloud goes in front of the sun?
Right.
You could picture this where all these cars are approaching an intersection and then like a cloud goes in front of the sun, then they all just stop. Right. So there's sources of energy that are in the moment that are not effective for cars because you want to be able to store it and use it on command. This is what made gasoline, so oil-derived products, so effective because they have a lot of chemical energy built into their molecules. You carry that with you. You load up over here, you carry it with you, you use it up, and then you reload at another destination. So the portability of energy is everything. All right. So Chuck, it all comes down to portability of your source of energy.
Okay.
That's what it is. It comes down to that. Okay. So here's an interesting fact. All right. Most of our transportation industry runs on gasoline or diesel. Okay.
Right.
And so we all know where to get that. You get that at a gas station. And we all know where the oil comes from. It's from the Middle East or from an Alaska pipeline or from Venezuela, wherever. And
wherever there's trouble in the world. If there's trouble in the world, you know we got some oil there. You know we got some oil there. You know what I mean? Anybody dropping bombs, got to be some oil there.
So oil is geopolitically significant.
Absolutely, yeah.
Because not everybody in the world has their own oil well where they just draw their own energy from Earth's crust.
Right.
Okay? So somebody's going to have it, and they're going to have more of it than you do. Now you have to negotiate for it, buy it. And are they your friend, or are they your enemy, or are they your frenemy? All right? So all of this matters so that you can drive your car to work each morning. So the point is, the geopolitics of access to oil influences things like your price of gas at the pump. Right? And so that's weird when you think about it. So what happens when you use an electric car? And yes, you do have this 100-year-old technology, the battery, but it's all we have for now. And the batteries are getting better than they were, but they're still batteries. But fine. All right. I've got a battery and I use it all up and I have to charge it.
Right.
So what is a battery? There's like all these electrons in one half of the battery and they have energy there. And by tapping that energy, the electrons move to the other side of the battery and then your battery's dead.
Okay.
In a non-rechargeable battery, you then throw it away. In a rechargeable battery, you reverse the current and the electrons move upstream. Think of them like salmon swimming upstream, and they go upstream and they lodge themselves on the opposite plate again. That's basically a battery.
But first they mate with another electron and die.
Okay. No, so that's where the salmon analogy breaks down. I'm sorry.
Okay. I'm sorry. Okay.
Sorry. And a bear is ready to eat them on the
exactly.
top.
Just swipes them out of the water.
Poor salmon. Be nice. A quick point there. A point we've made before, but it's worth saying in this moment. If you have a freshly dead battery, and then you put in the reverse charge, those electrons can lodge anywhere on that opposite plate that they happen to land.
Okay.
They got a zillion places to go.
Right.
Okay, to choose from. And then they land there. But when you're half charged, only half the spaces are left. When you're 90% charged, there's only 10% of the spaces left.
Gotcha.
Okay? All right. So the electrons have a harder time finding that remaining spot.
It's like musical chairs for electrons.
Yeah. or a big parking lot around a football stadium. If you're the first one there, park anywhere.
Right. That's true. Yeah.
And you can park within seconds.
Right.
But if you come later, there's a spot for you, but you got to find it. It could take you a half hour to park. Okay. Yes. So as the charge gets higher and higher on your battery, the time it takes to charge the rest of it continues to grow.
Right.
Okay. So just something to keep in mind.
So your battery is not screwing with you people. When it's not just like, breaking down on you in the last 10%, which
Right,
is fun,
right.
it takes forever.
Now I want to recharge my battery. It's electric. So I plug it into the wall. Oh, wait a minute. Well, where does the wall get its energy? From your regional power station.
Right.
Let's go there. So you walk down to the power station. Hey, folks, how are you making power today? And they show me the coal cars that drive up, dump coal into the hopper, and they burn the coal.
Bad news.
So those are fossil fuels, because coal comes from long dead plants, and this is carbon that had been sequestered for millions of years. That's now getting released into the atmosphere. So, Chuck, here's the catch with the coal cars that are dumping coal into the hoppers that are burning it in the electric company. So that electric company I'm making this up, but you get a sense of this. That electric company just invested in solar panels.
Okay.
They have a solar panel array out back. All right. What else do they have? They're tapped into a hydroelectric plant.
Nice.
All right. It's up the road a bit. Okay.
Cool.
And what else might they have?
Maybe a little offshore wind.
Maybe there are some winds. Okay. Some wind farms. So what's happening now is their energy profile that they generate can come from any combination of these sources. If you wanted to run your car off of wind energy, you couldn't, or solar, you couldn't, or hydroelectric, you couldn't. But the electric company can, and they can send it to your wall socket.
Right.
So the engine of your car doesn't have to be able to run off of 12 different ingredients. Your car doesn't have to be so designed as to be able to have solar panels and wind turbines. It doesn't have to have any of that. It just has to have a power plug.
Right.
It plugs into the wall. And then you can put pressure on the power companies to generate energies in whatever green way you dictate or want or desire. So I look forward to what that future is. Plus, an electric car, in principle, can talk to another electric car.
Absolutely.
Just think about that. So
That's
you say,
great.
excuse me, I want to change lanes now. Could you give me a little space? And the cars to my right separate. And they
Unless it's from Boston.
No.
If it's from Boston, it'd be like, screw you.
Keep looking up.